Welcome, attendees of the Fluid Power Innovation and Research Conference. My name is Eric Barth, and I'm an Associate Professor of Mechanical Engineering at Vanderbilt and Co-Deputy Director of the Center for Compact and Efficient Fluid Power, an NSF-funded engineering research center. Before I begin with introductions, I would like to thank the Center for Compact and Efficient Fluid Power for using Vanderbilt as its host, and I would like to personally thank our distinguished panelists for spending their time with us today. So thank you. Finally, thanks to you all for joining us at Vanderbilt University School of Engineering's Laboratory for Systems Integrity and Reliability. The focus of this session will be to discuss the future of public-private partnerships in innovation, student learning and training in areas of national need like energy-efficient fluid power, and ways to accelerate the transition of research to marketplace. To begin, I introduce Professor Kim Stelson, Director of the CCFP. Kim Stelson is the Director of the NSF-funded Engineering Research Center for Compact and Efficient Fluid Power. He is a professor in the Department of Mechanical Engineering at the University of Minnesota, where he has been since 1981. He received his bachelor's in mechanical engineering from Stanford University in 1974, and his master's and doctorate degrees in mechanical engineering from MIT in 1977 and 1982. His fluid power research includes work on hydraulic hybrid vehicles and hydrostatic transmissions for wind power. Before becoming involved in fluid power research, he was active in research in the modeling and control of manufacturing processes, especially metal forming, polymer processing, and composite materials manufacturing. Dr. Stelson has previously been Director of the Design and Manufacturing Division and Director of Graduate Studies for the Master's degree in Manufacturing Systems program at the University of Minnesota. He has been an Associate Technical Editor of the Journal of Dynamic Systems Measurement and Control, a journal that has twice awarded him the Rudolph Kaumann Best Paper Award, a very distinguished award. He is a Fellow of the American Association of the Advancement of Science. Kim?
Thank you all for being here. The title of the panel discussion we have today is Innovation, Marketplace, and Workforce. And this promises to be, I think, the high point this afternoon of our conference. We have been very much blessed by having this ERC funded by the National Science Foundation. And we're now near the end of our 10 years of NSF funding, which does cause us some concern, I must admit. But I am confident that we're going to get over this rough patch. And the reason is very simple. It is the strong partnership that we have between universities, industry, and government. And we have representatives from universities, industry, and government here today on this panel, and they will help guide us, I think, as we go through this transition and offer some of their experiences and wisdom. The moderator of the panel is the dean here at Vanderbilt, and so he will have the pleasure of introducing our distinguished panelists. I will give you a little bit of his background. Philippe Fauché has been dean of the Vanderbilt University School of Engineering since 2012. He has more than 30 years of experience in silicon photonics, nanoscience, and nanotechnology with silicon quantum dots, biosensors, electroluminescent materials and devices, and optical diagnosis. His research on porous SI and nanoscale SI and their applications to LEDs and displays, biosensors, nanoelectronic devices, solar cells, and optical interconnects has led to dozens of plenary invited and contributed publications and numerous invited conference presentations and seminars in North America, Japan, and Europe. In the 1980s, Dean Fauché was one of the originators of Princeton University's Center for Photonics and Optoelectronic Materials. In the 1990s, he created and ran the femtosecond laser facility at the University of Rochester's Center for Optoelectronics and Imaging. In 1998, he created the Center for Future Health, and in 2007, he created the Energy Research Initiative, both at Rochester. Also in 2007, he founded a successful startup, SIMPOR, which manufactures nanometer-thin porous membranes for applications in ultrafiltration and electronic microscopy. At Vanderbilt, he holds the rank of Professor of Electrical Engineering. He has overseen the creation of the Laboratory for Systems Integrity and Reliability, that's the lab we're in right now, and the Multi-Scale Modeling and Simulation Research Group, and the newest university-led building project, the 230,000 square foot Engineering and Science Building, designed to foster interdisciplinary collaboration, design, and entrepreneurship across the university campus. So let's give a warm welcome to Dean Fauché.
Thank you very much, and welcome everyone. I'll make a few short remarks and then go on to introduce each of the speakers, and then we'll start the panel discussion. But before I start, I would like to extend my appreciation to Professor Eric Barth for working tirelessly to organize this meeting, which, judging by how many people are here, is very successful, and also to Professor Doug Adams for being a gracious host in allowing us to meet in this landmark facility of ours, and I especially like this thing that flew in Vietnam. The Vanderbilt University School of Engineering places strong emphasis on at least three things. One is focused research excellence to help solve major societal problems. Two is a better preparation for our students to become entrepreneurs and in general agents of change. And three, creating closer ties with industry to help the region and the nation. And by the way, industry as well, if we can. To accomplish those primary goals, the school excels in establishing cross-cutting, multidisciplinary, and trans-institutional research programs. Our three major strategic areas of focus are medicine and health, security, and energy and natural resources. As was mentioned, from our new multi-scale modeling and simulation center to the Institute for Nanoscience and Engineering to this facility, the Laboratory for Systems Integrity and Reliability, the School of Engineering has become a central figure to Vanderbilt University in its efforts to create tomorrow's tools used to solve advanced problems and invent a unique experience, provide a unique experience to our students, graduate and undergraduate students. This facility in particular gives us the ability to validate the theoretical and computational modeling for which we are already well known. LASiR, because that's the name of this facility, as somebody who comes from optics, an acronym that's LASiR is so close to laser that it hurts my feelings sometimes. LASiR allows us to test the built environment, thus completing a critical piece of the problem-solving process. And this ability allows our students and faculty and partners to work with industry to speed products and processes to the market. This is right in line with the topic of discussion today. So the format of this panel is as follows. I will ask each panel member to make an opening statement limited to 5 minutes or less. And I don't have a big stick, so I'm not so sure. Plus, I'm not so sure I can use the big stick on my boss, the chancellor. And then we will have a series of questions touching on different topics, all right? So let's begin our discussion on public-private partnerships in innovation, student learning and training, and ways to accelerate the transition of research to the marketplace. We will start with brief statement from each of our distinguished panelists, and I would like to ask our chancellor to be the first one to start.
Well, I'm really honored to be the first one, and I guess that's some sort of protocol, although I'm the least qualified to probably be on the panel, so I feel very honored to be invited and included. And I think this is a great gathering. I want to compliment everybody who organized this and to tell you that it's a very, very important, exciting topic, and I really am pleased to be here. I'm going to probably be a broken record because as I see a lot of these topics, they really kind of fall into a number of buckets. The first, I think, will be culture. You know, how do you really create a culture at a university that really sees things connected to the outside world in a really everyday way, and getting the faculty and the students to say the most fundamental basic questions are always interesting to ask, but we're only here because we really make an impact on society. I think the other thing that you have to do is kind of build the sorts of programs that really drive the culture and the values. And I'll talk about this a lot, which is, you know, there's nothing, I've always said, there's nothing interesting about a department. There's nothing interesting, particularly even about a school. They are simply governing, organizing units that are harnessed to solve real everyday problems. And so, you know, I'll just be pounding away at breaking down the silos as you think of culture, of problem solving, outreach. How do you construct the university to then achieve that? And then how, in everything you do in terms of budgeting, space, rewards, visibility, you're actually putting the funds and the structures in place. So that's kind of how I see things from my perspective. You know, the old joke is a college president is like someone working in a graveyard. A lot of people underneath, nobody listens. But I really think my most important job is culture and mission and resource allocation that maps really tightly on those things.
Thank you very much, Angelo Zeppos. I asked to ask Ken Gray to be next.
Well, first, Chancellor, it's a real privilege to be on your campus. And on the drive over, it seems as though you've adopted about half of the city of Nashville for your campus too, and it's very impressive. And Kim, it's a real honor to be invited and to be seated here representing Caterpillar, and humbling to be with these three. I feel like I dropped out early when I heard the credentials. I want to make a couple of points quickly, because I want to really get to the questions. I think in front of the National Fluid Power Association a couple of years ago, I made the comment that we in this industry have a confidence problem. Some of you might remember that. People were shaking their head when I made that comment. But I really feel it's changing. And tell me it wasn't very many years ago when my dad and I were in the garage working on a carburetor, and he was teaching me how to rebuild a carburetor for what was then our daily driver. And now when you look under the hood of a car, it's all electronically controlled, and the type of change that the engine industry has experienced is what we're about to experience in the fluid power industry. We saw examples today walking around through the lab of putting the power density of hydraulics together with the ability to control the hydraulics that electronics provides, with the versatility of software on top of that. And also, I don't know where Josh was sitting, but the material science aspects of what we're bringing in together is really, really remarkable. We're about to enter into what I think is a renaissance period for the fluid power industry, and I really, really believe that. We've got tremendous, tremendous potential, and we're really excited at Caterpillar to be a part of that. The second thing I want to make is I want to outline what I think is our biggest challenge in industry. It's taking great ideas like we saw today, or you'll see more after the program, and commercializing them, really making them ready for our customers. That's really one of our biggest challenges. And we've had some successes with working with government recently to pull R&D dollars forward in the process. We're probably, I hope, still teaching undergraduates that for every dollar we spend to solve a problem during the concept phase, to solve a problem for a customer, is $10 to solve that same problem during development, is $100 to solve that problem once we're in pre-production, is $1,000 once that product gets into a customer's hands. And what we really need to do and are having some success doing between government and industry is taking great ideas from academics and working to get funding to pull R&D forward so that instead of subsidizing expensive technologies that make it to customers' hands and subsidizing them to make them affordable, we're actually investing R&D up front to make them saleable in the first place. And that's really where Caterpillar and I think many of our industry partners are headed. So anyway, again, very much appreciate being here again, Kim. Just a great honor to be here, and thank you all very, very much.
Thank you, Ken. Well, you have noticed a pattern. We go now to Tom Mason.
So, in thinking about the theme of partnerships, public-private partnerships, governments, universities, industry, I'm reminded that the Brookings Institution recently highlighted some work that we've been doing at Oak Ridge National Lab at our manufacturing demonstration facility as an example of how that can work. And I think some of you will have an opportunity to visit that facility tomorrow, so you'll get a chance to see it firsthand. But I think one of the important things that we see going on there, which in many ways is a similar environment to where we are right now, is a place where you can bring together all those people focused on problems of importance and doing it in a way that recognizes the reality of how innovation really happens. You know, we have this model that we all talk about of this linear model of progression and technology readiness levels, and it's all very orderly. You start with fundamental breakthroughs, and then you progress through a sequence of steps, and then a product occurs. And I'm sure anyone in this room who's been involved in things knows it's never that straightforward. There's all kinds of setbacks and do loops and problems you encounter. You have to bring, you know, not just technology improvements, but fundamental science too. And sometimes you don't even know what the right problems to solve are unless you have contact with the end user, with the eventual customers. And that's the sort of thing that can happen when you bring people together early in the research process, put them in an environment where you can have, in the case of MDF, companies that may want to use the technology, companies that may want to furnish some of the equipment, the tooling, materials suppliers. And of course, the example that we had recently that was a great example of this was working with a company called Local Motors, who basically, about 8 months ago, the CEO said, I'm going to 3D print the world's first 3D printed car at a trade show in Chicago in September. And at the time he made that statement, there was no device large enough to print something that large. There was no design for a vehicle, and there was no material you could make it out of that would work. And so actually we had to bring together all the expertise of the lab, the various vendors, Cincinnati Inc., Sabic, Tecmar, and of course Local Motors with a crowdsourcing model for their design to actually pull that thing off. And all the way along that process were numerous examples of these do loops I mentioned, the fact that it doesn't progress in the linear way. And I think that you can tackle those problems best when you can build these teams, understand the problems, and focus on them. And that's certainly something we're very interested in doing. There's another educational component that I think is interesting and important, and it really cuts across the whole educational spectrum from, you know, community college and workforce preparation all the way to, you know, higher ed and graduate degrees. And we're certainly trying to figure out ways to do that, working with our local community colleges on training programs that take people into the research facilities so they get hands-on experience that will be valuable as the new technologies get deployed into real manufacturing production environments. Some of the joint graduate programs we're doing, started out working with the University of Tennessee because they're just down the road, but we've been expanding it to, you know, the sort of regional research partners we have, which includes Vanderbilt, North Carolina State, and the other southeastern universities. It's tremendous experiences for the students, but it's also great for our staff because the level of excitement that you get just moves up onto a different logarithmic scale. And so those are just a few observations I have. Looking forward to the discussion.
Thank you, Tom.
Great.
So thank you. I'm Mark Johnson from the Advanced Manufacturing Office in the Department of Energy. I'm going to take a time out here for just for a second talking about students because this has been bothering me out of the corner of my eye. We have a bunch of students here, and we have a bunch of reserved seats here. Why don't we get the students to move down and get in a little bit closer here, if you don't mind.
I like that. I like that very much.
So, and I think that points out, you know, we're going to be talking a little bit about public-private partnerships, and what they are about are people at the heart of it, and working on challenging problems together. All of us are a lot smarter than any of us. People bring different perspectives to any problem. I don't care how fundamental the science and technology problem is, you bring someone else into that perspective, you're going to find something new and some new way to think about solving that problem. So what does the Advanced Manufacturing Office work on? Well, manufacturing, first of all, if you look at the official government definition of manufacturing, it's about a page long, and it uses the words manufacturing and advanced in the definition, which I'm pretty sure, you know, they teach in the English department here is not how you define something. So, well, you know, what manufacturing is, I think everyone gets it at their heart. You're making something, right? And what advanced manufacturing does, and this is what the United States excels at, is when we use technology to make it so we can be more competitive at making things. And that's the heart of what we're trying to drive towards. And how do you use that advanced technology? Well, it's unleashing the science and technology capabilities we have across our laboratories, our universities, and our small businesses across the country. And how do we bring that to bear on these manufacturing problems? And really kind of moving forward to making sure we're always at the latest and greatest technology. It always comes out of the United States. So we work across the US on this. We work very closely with our national labs. I think Tom pointed out our manufacturing demonstration facility. This is a pilot that's been supported by the Advanced Manufacturing Office within Oak Ridge. And it's been a great pilot over the last 2 or 3 years, actually the last 3 years, standing up to say, how do we reinvent that relationship in the national labs to public-private partnerships? We're starting to see the beginnings of those fruits of that benefit to kind of tear down the walls between the manufacturing community and the national labs. So it's a much more interactive relationship so we can get technologies out quicker. My goal is how do we wind up continuing and taking that to whatever we want to call it the next level. You know, it's kind of a euphemism. But how do we wind up doing that at all of the national labs across the country, as well as accelerating what's going on here at Oak Ridge? So with that, why don't we move on to the discussions today?
Let's thank Mark. So in the rest of the panel, I will ask specific questions addressed first to a specific individual, but I would urge all of you to jump after to complement. And if I don't hear anybody jumping, I will help you jump by asking you to follow up. So the first jumper will be the Chancellor of Vanderbilt University, and I have a question for you, Chancellor. The NSF-ERC program is specifically focused on doing cutting-edge research in the context of graduate education and training. Now, what is the most important thing academic institutions can do to train students, undergraduate and graduate students, and maybe even postdoctoral students, and nurture the kind of innovation that our nation's research enterprise, in fluid power, of course, but also in any other area, relies upon?
Well, I think I'll go back to my earlier comments. I think the most important thing we have to do, and here are the students, they can tell me if we're doing it. I guess they're here, so we're doing something right. I think you've got to present to students, and we really think of students, undergraduates, graduates, postdocs, all together, working on teams. You've got to present to them a broad set of problems that are really challenging and interesting, with great faculty, of course. But then, I think what we have found really successful is that the students work across departments and programs and disciplines, and that they're bringing, as Mark said, the kind of best of all of these different perspectives to solving a problem. Oh, this is really an interesting problem. Here's what I contribute. Boy, if we had a software solution, we could kind of move this forward even faster, skip a couple of steps. And so when I look at what we do really well, we call them trans-institutional programs, and we say, you know what? We have a problem in society, and we need to bring everyone together to try to solve this problem. And I think that's the sort of environment that's innovative and cutting edge and not silo-based, and that really in some way replicates the best of what's going to happen in the real world, which is working with a lot of different disciplines across departments and groups. So, you know, you can see it here, but I think of Michael Goldfarb's work, another colleague of ours who works on artificial limbs. And it's like, okay, where's my material science person? Where's my mechanical engineering person? Where's my software person? Where's my neuroscience person? Because I'm going to make this work in the brain as a natural movement. So I think that the presenting really complex, interesting problems, bringing all the different disciplines to bear with undergraduates, graduates, faculty working on teams is really important. The other thing I would say is you've got to, I think the tech transfer offices, and in tight budget times, they're very hard to support, but I think getting your tech transfer people really tight with your faculty and your students is very, very important. And that's where you can kind of start to see application, investment, reality coming true. So those would be the two things I'd focus on, Philippe.
Great, thank you. Ken, do you want to add anything from industry's perspective?
You know, I was going to, I didn't want to, but I'm glad you asked me to. The couple of things. That really is how industry works. I mean, it is, and that is where the best innovations come from. They never come from me. They come from my team. They come from those individuals that I bring to the team that are new. They usually come from what we like to say, from people who are they're not among the usual suspects. The ideas come from off-the-wall places, and that's really the way that it would happen. The other thing I would do, and if you forgive me if I offer some constructive criticism to the students that I saw present today, when we talk about technology transfer, the most important thing you can do oftentimes is tell a great story about why the technology you're working on is important. When we were talking, Mark, about what problem are you trying to solve, what utility are you trying to add, I think the technical presentations I saw today were fantastic, but what I really wanted to see were more storytellers, more impassioned descriptions about what we're doing and why we're doing it. And that would have helped you sell the idea and helped you transfer the technology.
Great, Mark.
I'll weigh in a little bit on the tech transfer part of it as well. Universities have to have a open and inviting environment to make sure that we can wind up having strong partnerships in place, people wind up working well together, understanding the rules of the road, all that sort of stuff. But at the same time, I think the most important tech transfer thing that any university does, any year, you may license 50 patents. You graduate 5,000 students. Each one of those is an individual tech transfer happening. And that is by far and away the most important, and it's a unique thing universities do. There's a lot of people developing technology around the country that do research. They have all the attributes. Universities uniquely are the only place that really develops that next generation of scientific leaders and get them out there. And that's the lifeblood of the entire enterprise of the technology that's out there.
Great.
That's music to my ears.
Yeah, I'd just like to pile on that, actually. You mentioned in my bio that I did a postdoc at Bell Labs, which was, you know, famous as a place that did a lot of innovation. And actually one of the researchers that I worked with there used to say, you know, I don't care about all this tech transfer stuff. The only tech transfer I care about is the moving van from Boston to Murray Hill.
Not Palo Alto?
Well, he was an MIT grad.
Well, you know, I mean, one of the most interesting things I always tell the governor and mayor is, I know you're recruiting a lot of businesses here, but every year I graduate X number of amazing kids and a lot of PhD scientists and engineers, but a lot of great undergraduates. you ought to start by saying, what am I doing to keep those people from getting in the moving van to go to Boston, Palo Alto, et cetera. And so I think we think of globalization as really important. One thing I think we have to focus on is where are the flow of people in America and the resources we have.
There was actually a great study done on this by the Regional Economic Development Agency in Cambridge in the UK, which within the European context, that's a region that has a real signature strength, particularly in biotech. And you know, it's not surprising. I mean, double helix structure was discovered there. You have Fred Sanger. There are a lot of great researchers at Cambridge University. And so they tried to look and say, how many of the companies in the Cambridge area are associated with IP that came out of Cambridge University? Almost none. How many companies are associated with people who came out of Cambridge University? Almost all of them. And so it's not to discount the importance of traditional tech transfer, because you need to put that legal protective framework around stuff in order for companies to extract value from it. But it really is about the people.
Yeah. So I think this was a very encouraging message that I heard from all of you. First, I heard that what's going on in this center is really good. Heard some advice for students on how to make it even better, and heard that students are really the engine of everything, right? So for those of you who are students, this is a good sign. Let me now to switch to a little bit of a different question, and let me start with you, Mark, if I may. Manufacturing includes many dimensions that are very energy intensive, right? Including materials extraction, handling, and processing. Now, fluid power as a power transmission system is involved in many of these steps. So if you look at the issue of energy efficiency at the systems level perspective, what do you think are the big ticket items where we can really improve the efficiency? Where should we focus?
So if you look at across the board on energy efficiency, first of all, what we look at in the office are how we can wind up reducing energy intensity of existing facilities out there, but also looking at downstream, how by developing that technology, do we wind up making something new available? So whether it's controlling the system in the manufacturing environment or in its end-use application, this whole idea of life cycle manufacturing, things like that, huge, huge impacts. We're sitting right in front of a large airframe. Huge impacts of how hydraulic power can wind up affecting positively the energy efficiency of those systems. So I would look at it exactly as you framed it up, saying, as we wind up solving the problem, at the end use, what is the problem we're trying to solve? Is life cycle energy utilization. It may be that you wind up making the turbines operate more effectively, or if you wind up making wind turbine blades pitch more effectively so they can generate power more effectively, that probably has a much larger impact from a systems perspective than the individual amount of energy you're saving on each one of those. It's what it's doing, what it's actuating. So embedding your solution into a much, much larger system, you can have huge multiplier effects as a result.
We hear a lot also about cyber physical systems and the impact they can have. Do you want to put those two things together, maybe?
Well, yeah, I was going to add a third thing in there, and this is again back for the students. You've got three convergences happening right now. You've got huge changes happening in the energy systems overall. You're looking at a huge increase in the amount of fuels available and what the fuel mixes are and what the cost of those fuels are. It's been more than a generation since the last time we've had this sort of a shift. We're also in a period of time where we're within about 5 to 10 years of a number of new technologies relative to clean energy and renewable energy, whether it's solar, whether it's wind, whether it's geothermal, where they become cost competitive, and we hit a crossover point on those cost points. So those are huge changes that are happening in the energy sector. You also have huge changes in the information technology sector. You know, suddenly you have sensors being ubiquitous and cheap, and controls cheap. I was walking through a metal processing facility not long ago where the people that are running this giant, it was a titanium smelter, and they were saying, well, we've got a 3-zone furnace here, and it was, you know, as big as this room. And I was thinking, you know, I've got more temperature zones in my cell phone because it's cheaper. So that just shows, you know, information technology and sensors, we can make them cheap, we can make them ubiquitous. So, and then the third trend that's happening is this whole direction towards sustainability, right? I think there's an increasing importance and increasing awareness, especially among the millennial generation and the next generation coming up, saying how do we wind up not only solving these technical problems, but solving them in a sustainable way so that the 8 billion people on the planet and growing wind up being able to utilize the resources as effectively as possible. So what that all calls out for is saying that these are all cyber-physical systems, as you said. The information technology coming together with the energy technology, coming together with sustainability so that we can wind up solving the really challenging technical problems that face society going forward.
Right. Ken, Tom, anything you want to follow up on this?
That was awfully good, Tom. You want to follow that up?
Well, you know, it's interesting that when you're thinking about hydraulic systems, historically, it's, you know, the real opportunity is that we've spent energy to move it this way. Now we're going to spend energy to move it that way. Right? And that's part of what's the thinking behind the hybrid systems. And so it tells me there's at least a factor of 2 available there, you know, minus losses. And even though every one of those opportunities is small, if you add them up over the enterprise where you see these systems deployed, it's a big number. Mm-hmm. And a lot of energy efficiency things, which is the, you know, that's our best near-term pathway to not only reducing costs, but reducing CO2 emissions is energy efficiency. Mm-hmm. A lot of that is harvesting those individual economies that may be small in their individual realizations, but in aggregate add up to a big number. And this is certainly one case where that's true.
It's a system discussion, and the analogy on the off-road vehicle space is, I think it's very, very similar. I think we were very focused on the engine itself, perhaps because of what the EPA was mandating that we be focused on. But where the real benefits have come in terms of improving efficiency and reducing fuel have been with an overall system view of first the vehicle. And then now that we've optimized that node, minimized that node, now we're looking across the system and how does the system work well together on a site to even further reduce fuel, even make that system even more efficient. And then at even broader scale, how do you make all of the equipment that a customer owns more efficient at a fleet scale? And so we're seeing, it's a little bit about, you know, I've always when we're starting a project, I always push very hard on what the scope of the project is because it often determines what the result is. If the scope is the engine, you get one result. If the scope is the machine system, you get a better result, more complex problem, and so on. But I think it's really a system and integration, optimization types of problems we're talking about.
Yeah, you know, I've got an interesting vantage point into current and future customers with, I think, high earnings potential. And so I'm always very interested in, you know, the millennials or the Gen X and all this stuff. And one thing that I think has happened is I started teaching in 1987. And I think this, maybe I'm just getting old, but I think there's something going on about consumer preferences and them looking holistically kind of at the things Ken was talking about, and then Mark threw this in. And I don't know, I think there is something about this generation that will set different expectations, not in some sort of what's my carbon footprint sort of thing, but just kind of psychologically moving that into a consumer choice, holistic determination. And I think it's different from what we've seen with other young kids coming along. And I hear this from people at other universities as well.
It's Yelp. Right? They
Yeah,
can look it up
no,
on this.
yeah,
Is that what it is?
yeah.
Tom, let me address a question directly to you. And Chancellor, I have a follow-up question in the same vein. Since you are at the biggest national lab by many metrics, Oak Ridge, as well as the other national labs, play a vital role in all phases of the research and development life cycle of technology, including, but not limited to, fluid power. Now, how do you envision the national labs participating in moving research from the lab in areas like manufacturing, fluid power, and others to increase the technology readiness level of the new innovation? And the follow-up question for you, Chancellor, would be how do you see the interaction between the universities and the national labs to achieve that same goal?
Well, I think the first thing is we do have a lot of capabilities in some of the underlying fundamental science ingredients to solving some of these problems. So modeling and simulation, for example, using supercomputers, or even maybe not so supercomputers, but using them in very effective ways to understand things like system performance, materials, novel new materials that may, enable improvements in terms of, weight, strength, cost, environmental footprint, durability. Really unique facilities for characterization, imaging, sensors, and typically available at no cost for work that's not proprietary. So available as a resource to the broader community, and then a tradition of really extensive partnership with universities and companies. Specifically in terms of fluid power, I think there are a couple of opportunities. One is the area of additive manufacturing or 3D printing, which allows you to embed a lot of complexity into structures at really no additional cost. And so Lonnie Love is sitting in the front. He's been working with systems for robotics that are hydraulically actuated, but all the tubing is built into the component as part of the 3D printing process. And so that reduces the cost dramatically, because now you don't have to go and, wire up these things in order to get them to work. They come off as built, almost ready to go. And the fact that that complexity comes for free allows you to do things that you couldn't do otherwise. So that's certainly interesting. We've been interested a lot in external field processing for lighter, stronger parts. Coating, superhydrophobic materials, which could improve in terms of losses in the systems, and also just the general susceptibility to various forms of degradation. Lightweight materials are going to be important. Low-cost carbon fiber is something that we've been very interested in. Get carbon fiber out of the mode where it's limited to really high-end aerospace applications or specialty sports materials where
we need to talk.
You're prepared to pay any amount just to shave one stroke off your golf score. And advanced energy storage is another area. So I think there are a number of examples like that where we have expertise and facilities that we want to make available that could certainly impact. And there are lots of examples of how to do those partnerships. In another area, one that we've been involved in is another NSF Engineering Research Center looking at the grid. And there are 12 university partners and affiliates, 20 or more industry partners, Oak Ridge, and also the National Renewable Energy Lab. So it's a big consortium, a lot of complexity to managing it, but on the other hand, in the way that Chancellor Zeppos was saying, if you need the neuroscientist or you need the software person, you can find them when you've got that kind of breadth. No single institution is going to have a monopoly in every area where you need the expertise for some of these problems.
So Chancellor Zeppos, how do you think national labs and universities, they already work together, but how can they even work together better?
Well, I think that this might be self-evident, but universities are not really good at leveraging assets, even on their own campuses. And the old line that our university is 10 great colleges and universities committed to cutting-edge research, training the best students, all to get tied together by the common problem of parking. How do you really think of the university as one? Okay? So you got to start out locally and say, it's just like a company. Here are my assets. How do I leverage this thing? And you can go back to the start of a Google or a Facebook, and they're sitting around saying, what do we have? What are we going to leverage? And it's kind of like a lot of information and advertising. But that's still not enough. So I think universities need to go through a kind of conceptual change about leveraging assets and really sitting down and saying, what are the unique assets we have? And then if I have a national lab right down the road, I've got to leverage that. Because now you're starting to say, if I get over there, a lot of other people aren't going to be able to do what I can do, and they're going to fall behind because they can't even figure out how to leverage their assets. So I think you've got to design programs, you've got to build tracks of graduate education, undergraduate education, linkages with industry that start to say not what do I want to do, but what can we do with national labs and universities that nobody else can do. And that's what I think is kind of from my perch. You know, if someone says, well, I want to start a program in X, I'm like, why would we start X? We're not even very good in X. Well, if you give me $100 million, we could have a great program in X. And I was like, okay, that means someone else has the program, and we're probably going to get slaughtered because we don't have advantages. So I think that whole mindset needs to change. Then we need to be less parochial about our faculty and students. And we just say, hey, this person could go to Oak Ridge and do some really great work. And then it's kind of like, well, but it's my graduate student, and you know, so joint appointments, joint training, and the university kind of being a little less parochial, but then kind of rolling your sleeves up a little bit and getting into some of the messy funds flows as well. That's kind of my perch.
You know, you may have an opportunity to leverage that industry does not have in this case, because ultimately competition prevents us from leveraging the scale that we often need to leverage across an industry. So you actually may have an opportunity that we don't have, that would be of great benefit to society if you can make it work.
Well, we also have a little bit longer time frame. I mean, you know,
that is true.
Listen,
I mean, 12 months.
Right, well, you know, which is 4 quarters. You know,
yeah.
And I feel like that longer time frame allows me to say build to last and have a little bit more commitment, and that's just a luxury and a flaw as well, because it may lead to my sclerotic behavior as well.
Mark, you wanted to?
I think the points you're pointing out here are exactly the power of these public-private partnerships. Because I guarantee you, Tom, have you ever spent time having to resolve, I don't know, office space and parking issues and things around a national lab? Every large institution does. Every, you know, the political fights are so high because the stakes are so low often, right, on some of these things. But at the same time, what we have to do is change the conversation. Right? And I think that's what these public-private partnerships do, is we pivoted it from being a discussion about what we do and where we should build to having an organization on the outside or a group of companies coming in from the outside and say, you know, we can't solve this problem by ourselves. There is a need for this. Please, somebody help us. And from a marketing perspective, that's called market pull, right? And you're turning that conversation around from what do we develop so someday we can get that out there to someone coming in and saying, build this capability for us. Please, if you solve that, there'll be a problem that you'll overcome. What's wonderful about it is in doing that, you can have a company come to you that sounds with a very practical, bottom line, I've got to get a product out kind of question, that suddenly when you open it up becomes a very rich technical or scientific challenge that's out there. So I'm going to give an example from one of our mutual colleagues actually this past week. So the folks that developed, we were talking about this at lunch today, that developed the blue LED, Suji Nakamura. He didn't come at this from the perspective of saying, I'm a scientist, I'm going to figure out the basics of the material science and someday work this out, and then once I do the quantum mechanics and work this out, I'll be able to build a blue LED. He started from the top down. I have a company that I'm in that makes television phosphors right now, and I need something that can replace that. And what he solved was actually a very mundane engineering fluid flow problem, and an annealing problem. That as a result of that, last week he was awarded the Nobel Prize in Physics, or selected for the Nobel Prize for Physics. There are still scientists to this day in my own academic department, I'm certain at Vanderbilt, that are working out the science about how this actually works. That's great. But it inverted the model. It said, we've got a very practical problem, how do we solve it? And we'll use our science and technology to get the best insight into it. We'll use all the tools we have in our national labs. We'll use all the tools we have at our laboratories. But we'll get to the problem solution first, and then that'll open up a new technical area. And I think that's the beauty of these public-private partnerships.
So this is very encouraging. It seems that indeed there is a good reason to have a public-private partnership with national labs as well. That sounds very good. Ken Gray, I want to now, actually, what you just said is a nice segue into this. The question I was going to ask you, which I will ask you, and then I'll follow that by something that came up when Mark was speaking. And the question that I'm starting from is, what are the technological directions in which construction equipment is headed? What are the trends? And how do advances in fluid power support that, in terms of efficiency, reliability, noise, leakage, anything that makes an impact? What are the areas of research you see the greatest needs, and where are there needs that you cannot meet today?
I'm gonna try to keep that whole question in my mind. First of all, I think
I can repeat it as often as you want.
No. Did it just get worse, Philippe?
No, we're getting older. We were talking about this. First of all, let's talk about what customers tell us that they want. Let's start with that. I think innovation really has to start and end with them, and it has to satisfy a need or provide something that they need, and ultimately, if it's really innovative, as Edison would say, they're going to buy it. Would have said, I'm successful when they buy it. And so it really begins and ends with them. So what they tell us, and historically have told us, is the conversation always starts with reliability and durability, which are words they really don't understand. They use them interchangeably. It needs to be reliable for a very long time, is what I most often hear. And then it has to perform. It has to do a job really well. It's in a terrible environment. It has to get the job done. But what we're hearing more of today than we heard even 5 years ago or even 3 years ago is that margins in their businesses are very thin. I have a customer who's fond of saying that the price of dirt is getting lower, going lower. My margins are lower. The price of dirt is going down. And so owning and operating cost has become a central theme of all of these discussions. And then kind of a ticket to the dance, we talked about sustainability. I really think sustainability has become a ticket to the dance. And part of the sustainability discussion is around safety. It's always been very, very important, but now, as litigious as our society has become, there's even more of a business reason for safety to be of great concern to our customers. So how does all this fit into what we're here talking about today? Power density of hydraulics plays very, very well with reducing owning and operating costs, with performing well, and with highly reliable product. And I began my comments by saying hydraulics with electronics on top, software for versatility and control, and then material science. Every pound I take out of the front structure of a machine, I would not use fuel to throw the front of the machine around. I would be directing all of that fuel consumption to moving material. So every bit of weight I can take out of a machine turns into reduced fuel savings, turns into reduced emissions, turns into lower costs for my customers. From a safety standpoint, from a software control, I don't think most people that run a piece of equipment realize that an operator can make a mistake and actually pull the tool that he's running right through his own operator environment. So e-fencing and that sort of thing, software control, those types of things, again, I think there are just a huge number of opportunities for us in this space.
Before anybody jumps on this, I want to follow this up. And in Kim's introduction, he mentioned many years ago, I started a center called the Center for Future Health. And we spent, before we got started, we spent 2 years inviting medical doctors to speak to us, engineers and scientists. And the rule of the game was, don't tell us what your successes are. Tell us what your wish list is.
Yeah.
Tell us the things you can't do yet you wish you could do.
What are you dreaming?
Do you have any, so what are you dreaming?
What are you dreaming
What does
about
Caterpillar dream about? Besides higher stock market and things.
I cannot officially use the word dominate, so I won't. You know, we really want our customers to make more money, and I know it's a simple thing, but you know, we want our customers to make more money choosing our systems than they would make using anyone else's. That's really fundamentally what we want to do, because we know if they make more money with our equipment, they'll come back to us. That's the whole idea. And as we're doing that, we want to do so in a very, very sustainable way. One of our 5 core values as a company is sustainability, and it always has been. And when we articulated that for our teams finally, that sustainability was a core value, their response was, well, it's about time. We've been thinking that way for 25 years, and you leaders in the company finally caught up with where we think our core values are. So they would make more money with our products than anyone else's, and they would do so in a very sustainable manner. I mean, that's our dream. It really is.
Any follow-up on this?
I have to say, since I'm you know, the head of a not-for-profit, I have no problem with that. I just think, you know, as I always emphasize, a not-for-profit means you don't make a margin. All it means is I don't have shareholders that I have to pay dividends to. And you know, our goal at Vanderbilt is, let's do really great things, and then we just take that money and plow it back into all the things you see in here. So just from a college president standpoint, I have a different tax status.
Right.
And you know, but I hear exactly what you're saying.
I mean, it's really what, in the end, that's what we're trying to do. I mean, that's what all of us in this industry are trying to do, help our customers be more and more effective in what they do.
So is the U.S. a leader in fluid powers? Or where do we stand? I mean, what is the status of the industry in this country?
My perspective is, our perspective is we are leaders, but that leadership is at risk. And let's start with the leadership side. Our greatest asset is our people and how innovative they are. And I think what I'm enjoying, as I'm enjoying being with you today, Chancellor, and your team and your students, is this is such a breeding ground for innovative ideas, and that really, the people that the students that you create really are the competitive advantage we have in the United States. They really, really are. The innovative ideas, I always tell my marketing friends at Caterpillar, the most innovative, creative people at Caterpillar are engineers. And they love to hear that. I mean, they really do. But where do you think all these wonderful products come from? They come from the students that you're all working so hard to educate. And I really think that's our biggest asset. On the other side, Asia is coming really, really hard. And they are going to figure out how to manufacture high value added hydraulic componentry. And when they do, it'll be more of a challenge for us to maintain our perch on the top. And it just means we cannot rest on our laurels. It just means we have to continue to get better. We have to continue to work. We have to continue to innovate. We have to continue to do the things that we do well.
I think you're pointing out exactly what this happens in industry after industry after industry in the United States. Is every industry leader you'd get together and you'd say, yeah, we have the best technology out there. We're the industry leader in this segment, whatever the segment is. But boy, we have someone coming up and we're competing. Competition isn't bad. That's an excuse for even us to invent even further. And that's what we do over and over and over again. That's what the heart of, you know, the entire information technology field has been, you know, develop the next product, develop the next technology. We always grow out of every economic downturn by not getting back to our previous industries, but inventing the next one and growing from there.
Yeah.
And that's really the heart and the strength of how the United States continues to be, by far and away, the best place in the world for getting technologies out and moving them into the marketplace.
Yeah. Can I get on my soapbox, Philippe? Of course.
It's a box. We're up on one.
Yeah. Well, I have to say, I think that Ken and Mark have hit on a key point that I want to emphasize. And it's people and certain values that we find in this country. And it's freedom of expression, ideas. What if I invent this thing could go away, but that's okay. And don't ever underestimate those and the cluster of them and their association with what I call academic freedom. They really are hand in hand together. And that's why people still want to come to work and go to school here. I tell our trustees, I said, this is an extraordinary environment for training extraordinary people. And they will want to stay and come to America, but there could be a time where the people we train will go back and teach and discover. Their students, their young people may say, you know what, I can stay here and I don't need to go there. And then there could be a day, shockingly, where our best students may say, we'll go over there and stay there. And people say that would never happen. And I say, well, that might be Great Britain at some, when did people start coming to us? It wasn't in 1776. We earned this, and I think it's really important to understand that, that there's something about this ability to inquire and ask questions that we have to really treasure. The other thing I think is I am very heartened by, let me emphasize, a really important partnership, which is the industry academic partnership on funding of research in America. And the partnerships that I see coming from Caterpillar, from C-suites all over, saying, this ability to get private capital, university capital, government funding, that's bipartisan. And I have to do things that they call lobbying, although I don't. When you talk, it's a bipartisan issue. And when you tie it to where is this country going, I think it's a real winning argument. And we can't ever let that go.
Well, that was a rousing speech. Thank you.
I'll be announcing my candidacy.
For what?
I'm leaving this state.
I don't know.
I want to know.
I'm waiting to get drafted, Philippe.
I think you've already got the job.
Yeah, best job in the world.
Well, let me ask you, we have about 15 minutes of this panel, so it's about time to take a 30-second break here. How many of you were born after 1974? Can I see a show of hand? That's quite a lot of you, right? In 1974, I bought what was called a handheld calculator. Some of you remember this, the FPIRC14, and I had a little problem with it. And so I had to open it. And you know where it was manufactured? 1974, Singapore. So creativity and the mind power is what drives this country, not really what comes after that necessarily. It's really always being at the cutting edge of creation. If you're not, you lived for 4 years, as I said, very close to where I lived in Belgium, and that region of Belgium did not make that transition. And all the industry that were dying died, and nothing else was created. And that was a real problem. You are one of the exceptions. Thank you again. Tom Mason, I want to come back to you with a slightly different question. I mean, you have been in academia, you have been at Bell Labs, you have been in national labs, you have been at quite a few places, I understand, in Canada and in the US as well. So we have a lot of students in the audience, probably almost everybody who raised their hands a few seconds ago. What kind of advice can you give those students and postdocs who are here?
Well, actually, my son's a freshman in university and trying to think of his what he should major in. So I have the opportunity to give lots of advice, which is ignored.
Perfect.
So I guess I could just keep on with
Yeah.
No, we see if you can increase your batting average there.
Well, you know, I don't think there's any great secret in the sense that the most important thing, and everyone will tell you this, is to find something that really motivates you. Now, the reason that's important is because you're probably going to have to work pretty hard at it, and so if you're going to have to work pretty hard at it, it better be something that you want to do. There was an interesting study done by a faculty member at Tufts University looking at success in entrepreneurial activities, and something like 88% of entrepreneurs were successful not because their idea was particularly novel, but they just executed better than anyone else. So, you know, the other 12% had a better idea maybe, but, you know, in the end, a lot of it really matters, you know, on the quality and fidelity of execution. And that requires focus. And focus requires, you know, commitment and buy-in. So I think, you know, that's certainly the most important thing. I think, you know, particularly in a world that works the way that was described with Caterpillar and some of the things that the Chancellor was talking about, where you've got to be, you know, drawing on different sorts of expertise, finding environments where you can do that and getting comfortable talking with people whose jargon is different from yours is very important. You know, a lot of it is understanding the dictionary or the vocabulary of people in other fields. I think it actually helps with the focus because it's very stimulating, and when you throw yourself into that environment, you start learning very quickly, and that's a very gratifying experience. And certainly if I look at you mentioned I've moved around, been in different sorts of environments, the thing I've always liked when I've started to do something new is that the slope on the learning curve jumps up. And that's a tremendous thing. And even if you move within the same organization, as you move into a new position, suddenly you find you're learning again and you're learning fast, and that is, for me anyway, the best motivation. And you know, when I get to the point where I think I really understand how things work, then that means it's time for a new assignment.
Yeah, I get bored.
Yeah.
So that means change is forever, right? That's what you just said. Is that another way of phrasing that?
Sure.
Change is steady state, which for engineers would be an interesting concept, but I think that's true.
I think it's the same in industry too, and I mean, you know, in academics or industry, I think the biggest, and I love your advice. The most important advice I give to young people coming in the company or students that I'm talking to is find something you love to do. Just find something you love to do. You'll be enormously successful relative to working in a field you don't enjoy.
Yeah, you know, I have to say, we did this exercise this year of strategic planning, and I sat around with just about every constituency except the football staff and said, what do you want one of our students to leave with for life? And it was, you know, a good ethical, moral compass, but it was lifelong curiosity and the ability to always want to learn more. And even, you know, you're young, you'll be like me someday, old. But I'll never forget my first assignment as a lawyer was cell phones. And it was a cell phone licensing process. I didn't know anything about cell phones. And now I have the senior partner in the law firm who might have known Alexander Graham Bell personally, supervising this project. And it was, you know, I remember this, it was like, okay, we're going to give it to a local carrier, and then the local Bell operating company in ATT is going to get this. Other two licenses. And it was like, there is no ATT with Bell operating companies anymore. Whatever the cell phones were, whatever you think you have now, it's going to be like, you're going to be like me. You're going to say, how do I, as someone old, adapt with new things? Because even though you're young, you'll be like me someday. And that lifelong curiosity and passion together that they mentioned to me it's kind of what keeps me going every day. And I've been at Vanderbilt 28 years. It's like, I didn't know that. And sometimes it's like, I didn't know that. So I think it's really important to realize that you're on the cutting edge, but the edge is going to keep cutting. And you've got to go through your whole life saying, how am I not a square? How am I still on top of this? How am I keeping up with these young people? That's the secret.
But the other part of that, I think that's good. I kind of look at 3 attributes when I'm bringing someone into my own organization. And the first one by far and away is, are they fearless, right? So it's not a matter of wanting to do this because it's some sort of defensiveness. It's more saying, I want to know this. You know, you're unafraid of saying, how do we just reinvent everything going forward? The other thing is just openness, right? Openness to new ideas is unreplaceable out there. And the third thing, you were talking about studies of entrepreneurs. Another thing that's found on the dimensions of personalities that correlate with success in entrepreneurship more than anything else, and I know this sounds strange, is conscientiousness. An extreme case of conscientiousness is you're always doing a to-do list, but you want to be in charge of everything that goes on that to-do list. That makes you a good manager, because then you say what matters, what doesn't matter, putting it on there and coming through with what you say you're going to do. So, yep, find the things you're going to do, pursue it fearlessly, you go out there and grab the world and take charge of it. And it's every generation gets this opportunity. It's wonderful.
So we're getting very close to the end here. I'll just have one question coming back to perhaps a slightly more technical side of things, because we have gone from very technical to 10,000, 30,000 feet, and back to very technical now by a question. And maybe I'll direct that question to you especially to begin with, is what are the sort of new areas, new fields that fluid power can impact? Where do you see that? Is there any new directions, completely new departures? You know, we talked earlier, you mentioned the example of his name is Nakamura, right? Who went from an old technology to a new technology. That was a major breakthrough that changed everything. And of course, you have in your neighborhood a lab called Cree that advertises on TV now. And I remember when I was on the faculty at yet another university, we said, those people will never succeed. Well, now they make money, presumably. So, yeah. So what do you think is there a field in which fluid power doesn't touch yet and should or will?
I think you can look at some, I'm sorry, was that to you?
No, it's all to you, it's all of you.
I think you can look at kind of trends out there across energy systems, and any system out there is things are smaller, they're more efficient, and they're lower cost. So you look at a number of fields out there. So at Oak Ridge, the demonstration that Tom pointed out of printing a 3-dimensional car. When he says printing a 3-dimensional car, he's not talking about a little like tabletop car. This was a car that had an electric motor in it that 2 people could sit down in and drive down the road. It's actually a pretty fun car to drive around. But the really cool innovation on that is that you printed a car and you manufactured a car in a device the size of this helicopter, half the size of this helicopter. So in the same week where you've got the leader of Tesla Motors out there saying, I'm going to build a gigafactory, this started a trend in microfactories. That's a business model disruption. So you look at other industries out there, the chemical industry. How can you take a factory that's the size of 100 acres that you'd use for manufacturing new chemicals and put that so it's cost effectively on the footprint of this stage? So things are going to get smaller, they're going to get more information intense, and you need to move things around in any environment like that. There's a need for fluid power to be able to do that. It's not today's fluid power, I guarantee you that. You're pushing the envelope of what today's fluid power is. This is going to continue to change, it's going to continue to change, continue to change.
Ken? Tom?
I think you're I think you're absolutely spot on. I think the other area in our business that, again, it's these systems working together, but learning machines that really, I think it's, construction isn't like a mining operation where you've got a very predefined thing that you're going to put in with a set of equipment. You're going to have machines that learn how to be more effective in a particular environment, or that teach their operator how to be more effective in a given environment. I really think that technology is we don't know where that's going to take us, but I think that's a field that we're going to see much more development in the next few short years.
Okay, I'm going to wrap up with perhaps 1 minute of summary, at least what my take-home message is from this. First, I'm very encouraged. I'm very optimistic about this field. It's not a field that I knew a whole lot about, because I specialize in things that are on the atomic scale, so it's a little bit different from even things like this. But it looks like there is actually a lot of action and lots of things going on, lots of needs, lots of opportunities for partnership between government, national lab, industry, and universities. That there is the understanding that we don't all work with the same horizon, the same time, the deadlines. You know, that industry is a much more urgent need. Academia develops things for a longer term, and probably national labs somehow fit in between. I think we heard a lot of encouraging words for students working in this field and students in general. And I would like to end up simply by naming again our 4 panelists: Nick Zeppos, Ken Gray, Tom Mason, Mark Johnson, and thank the 4 of them for their fantastic contribution. Thank you very much.